introduce what is periodic table. So here I have one periodic table. So for periodic table, it arranged the element according to their atomic number. So according to the atomic number, elements are arranged inside the periodic table according to the increasing atomic number from number 1, 2, 3, 4 like this, okay? So, for example, the first one is hydrogen. The atomic number is 1. And then, other elements are also arranged according to the atomic number. So, it is not related to the mass number, but the atomic number. So, for a periodic table, we divide them into periods and groups. So let me introduce what is a period for a periodic table. So the horizontal row are called period. So the horizontal rows are called period. So and then for the columns, so this is called period. For example, hydrogen and helium are called first period. And then period 2 we have lithium, beryllium, boron, carbon, nitrogen to neon. So this is period 2. Okay, for the horizontal rows, they are called periods. And then for the vertical columns, they are called groups. So we have, for example, lithium, sodium, potassium, and then other elements. Because I don't want to include all the elements here to make it complicated, we just have chopped it here. So this is called group 1. So this is the first group, and then we have another group. These are the vertical columns, so they are groups. Okay, many groups here. And then we still have some elements that are not grouped inside these groups. They are called transition metal in the middle. So we will talk about these when we are in Form 5, okay? So transition metal, we will talk about this later. But for the groups, we will talk about the groups and period today. So the vertical columns are called groups. So we have main groups elements. You may not have these in notes. It's okay. You just take a look here. So for these, we have number here, or except hydrogen. Sorry, hydrogen should not be here. So hydrogen should be somewhere here. So because it has some unusual property, so it is not included in any groups. So hydrogen is not included in any groups. All right. So in between, we have transition metal that I just mentioned. We will talk about that in Form 5. And then we have many main groups elements. So the yellow one are the main group elements. So how can we arrange different elements inside the periodic table? It is according to the electron arrangement. All right? Arranged. They are arranged by the electronic arrangement. So, for example, here. So we are on page 2 already, okay? So, how can different elements arrange inside the periodic table? Firstly, for the period number, for example, period 1, what's meant by period 1? If the elements are inside period 1, they are arranged in period 1, that means they have just one occupied electron shell. What is occupied electron shell? That means they have only one electron shell that have electrons. 嗱，明唔明啊？即係話，如果佢就係得一層電子嘅話咧，佢就 period 1咯。嗱，點先叫一層電子？譬如 hydrogen 1就得一粒電子嘅啫。咁所以 就係得第一層電子 fill 咗。Helium 2淨係得第一層電子 fill 咗，做兩粒電子擺晒入去啊嘛，咁所以佢就 period 1咯。好啦 ，period 2又點呢？你會見到 period 2 you can see for lithium is here 2 1 2 2 beryllium boron 2 3 up to neon 2 8 they have 2 filled electron shell 係啦，有兩層電子即係有兩層嘅係啦，有兩層嘅電子，咁所以佢就係 period 2咯。即係佢有幾多層電子就係 period 幾啊？明唔明啊 ？OK， 好啦，咁 period 3又繼續睇啦。period 3咧就係有三層電子咯，呢啲即係由 sodium 至到 argon 全部都係有三層電子嘅。OK，they have 3 occupied electron shells, so they are in period 3. Alright. So here, so elements in the same period have the same number of occupied electron shells. They have the same number of occupied electron shells. So it is number 7, point number 7. Elements in the same period have the same number of occupied electron shells. So then, how about group number? So for group number, it is equal to their outermost shell electron number. For example, for group 1, except hydrogen doesn't belong to any group, okay? But for group 1 metal, for example, lithium, sodium, potassium, rubidium, they all have one outermost shell electrons. So they all have one outermost shell electron, so they are in group 1. Alright? And then for group 2, they all have 2 outermost shell electrons. Okay, class. So you may ask that if you need to remember all this electronic arrangement. So I want to tell you, you just need to know how the electrons are arranged for first 20 elements. For period 5, for example, rubidium and this strontium, you need not to memorize their electronic arrangement, alright? You just need to know the electronic arrangement of first 20 elements. But you need to know for group 1, they all have one outermost shell electron. And for group 6, for example, they all have 6 outermost shell electrons. And their group number corresponds to the number of outermost shell electrons they have. Alright? So, the elements in the same groups have the same number of electrons in their outermost shell. Alright? So the electronic arrangement of an atom of an element determine the chemical properties. So you need to know that. So for chemical property of an element, it depends on the electronic arrangement of an element. So if the elements are in the same group, they have similar chemical properties. So important here. So elements in the same group will have the same, similar, not same, okay, will have similar chemical properties because they have the same number of outermost shells electrons. So because the outermost shell electrons are normally responsible for the reaction, so if they have the same number of outermost shell electrons, they will have similar chemical properties.